focusing on factors affecting enzymes. There are 5 factors that affect rate of enzyme control reaction: temperature, pH, substrate concentration, enzyme concentration, and inhibitors, 2 types of inhibitors. The key focus is really going to be on our active site. So this is the enzyme here, and the section in blue is highlighting the unique 3D shape, the unique shape of our active site. Let's start off with temperature. This is a graph here. We can see the rate of reaction is on this y-axis. On the x-axis is the temperature is increasing. We should be able to explain and describe and explain the temperature and rate of reaction graph using certain keywords in your answer. Generally, as you can see, very superficially or in a summarized way, we can say that as the temperature is increasing, the rate of reaction increases, and then when it goes above the optimal temperature, the rate of reaction drops down eventually to 0. So in a very low temperature, there is less kinetic energy, and that's the word you need to use for your answers in your exam: kinetic energy, which means that there is less successful collision between the substrate and the enzyme, the active site of the enzyme, and that will mean you are forming less enzyme substrate complex, so the rate of reaction is low. When the temperature is very high, the enzyme has denatured. This means the active site has changed shape, and therefore the substrate can no longer fit, and hence the rate of reaction decreases all the way to 0. The active site is maintained by bonds between the amino acid. When writing our answers, you cannot mention bonds only, generally bonds, you will not get a mark for that. You need to specify the bond, such as hydrogen bond, ionic bond. So if the active site has changed shape, that means the substrate can no longer fit, which means you will not have enzyme substrate complex being formed. The rate of reaction will drop down. pH, you can see here that this is a rate of reaction and pH. In this example, the enzyme that we are talking about has an optimal pH of 7. Given said that, you need to be really made aware that different enzymes have different optimal pH, and in our case, for this particular enzyme, we are saying the optimal pH is 7. In extreme pH change, meaning if the pH is too high or too low from the optimal pH, so in here, for this example, pH 3 will be too low and pH 11 will be too high. Either of these extreme pH change will cause the charge of the amino acids in the active site to change, to alter. If these charges of the amino acid change, this leads to the breaking of the bonds which is maintaining the tertiary structure. And we mentioned about this bond. You need to specify which bonds, examples of bond, such as hydrogen bond, ionic bond. If you have broken the bond, that means the active site has changed shape, which means the enzyme is now denatured. And then, if it's denatured, you will not have substrate fitting in, which means you will have less enzyme substrate complexes, and the rate of reaction will decrease. Many students lose mark in these questions because they fail to use keywords. So in here I have 1 to 4 for you. You can make notes how to answer these, ensuring that these keywords are in your answer. So if the enzyme denatures, the active site has changed shape, substrate is no longer complementary to the active site, which means fewer enzyme substrate complexes formed, and the rate of reaction decreases. Substrate and enzyme concentration. In this graph here, we have rate of reaction and substrate concentration. As you increase the substrate, you're increasing the rate of reaction. And the key thing to understand is only on this image here. We have enzyme, active site, we have substrate. When they collide, we say this is successful collision. These are key words you should be mentioning in your answer. Successful collisions. It forms enzyme substrate complex, another key word to mention. If there is more collision, more complexes, enzyme substrate complexes are formed. But these collisions, they occur randomly, in total randomness. There's no guide to it, there's no precision to it. Just randomly bumping into each other by chance, and then you have a complex being formed. So this randomness collision, i.e. making a successful collision, making that collision successful, the chances of that success is increased if you have more substrate or if you have more enzymes. So let's look at the first one. If the substrate is insufficient, meaning you have less substrate and more enzymes in comparison, that means you have a fewer successful collisions between the enzyme and the substrate because you're deficient in the substrate. This will mean you're forming less enzyme substrate complexes, and this will decrease the rate of reaction. If you want to increase the rate of reaction, just add in the substrate. So we can reverse this. If the concentration of the substrate is increasing, then what we have more successful collision between the enzyme and the substrate, forming more enzyme substrate complexes, which will increase the rate of reaction. This is where our graph goes flat, plateaus here, and this is telling us that all the enzymes is fully occupied. You can no longer increase it any further. Let's go into our enzyme concentration. I have here rate of reaction and enzyme concentration. You can see here as you increase the concentration of enzyme, the rate of reaction is increasing. And the reason because is as you increase the enzyme, there is more successful collision between the enzyme active site and the substrate, which means you are forming more enzyme substrate complexes, which means you are increasing the rate of reaction. You can see me over time and so many times using the word enzyme substrate complexes, active site, substrate, collision, because these are the words you have to mention to get those marks. If the concentration of enzyme is insufficient, is less, then this means all the active site will have become saturated, have become occupied with substrates. You have less enzymes, more substrate, that means all the enzymes are fully occupied, fully saturated. So the rate of reaction will not increase any further until you add more enzymes. That is the case if the enzyme concentration is insufficient. Enzyme inhibitors. We have two types of inhibitors, competitive and non-competitive. Let's go on to the competitive inhibitor. Looking at this graph, this diagram here, this image, it's not a graph, sorry, it's like this image here. Now, this image will really help us to understand what is a competitive inhibitor. I have my enzyme here, I have my active site, and I have two things. I have an inhibitor here, and over there I have a substrate. Now, if you look into carefully, the substrate and the inhibitor, they have a similar shape, not the same shape, similar shape. So the inhibitor has a similar shape to the substrate. So therefore, this inhibitor can bind to this active site, and it's going to form an inhibitor enzyme complex. So competitive inhibitor, they are able to bind to the active site as it has a similar shape to the substrate. Now when it binds to it, it forms a complex, and this prevents the substrate from binding. This prevents the substrate from binding. So therefore, you are going to have less substrate fitting in, forming less enzyme substrate complexes. Now the key thing to understand is this inhibitor, which is bound here, does not stay there forever. It actually, after some time, it comes off. So this inhibitor is not bound to the active site permanently. It is not permanent. When it leaves the active site, another molecule can take its place. It can be the inhibitor, or it can be your substrate. So there is a competition. There's a competition between the inhibitor and a competition between the inhibitor and the substrate. So you can reverse this. This can be reversed. The effect of the inhibitor is reduced if you have more substrate concentration. If you increase the substrate so it outcompetes the inhibitor, you have reduced the effect of the substrate, of the inhibitor. Looking at this graph here, we have rate of reaction and substrate concentration. I want us to focus only on two of the lines. The first one here, which is showing you a rate of reaction in which there is enzymes, but there is no inhibitor. As you can see, the rate of reaction increases, and this around here is the maximum. This is maximum rate of reaction. I want us to understand, what does that even mean? When the graph, when it flattens out, when it plateaus, it does not increase further. What is that telling us? A, this is the maximum rate of reaction. That's fine. What does that mean? That means all the enzymes are fully saturated. There's no more free enzymes. That's the maximum rate of reaction. And we have achieved it around here. Now, if you look at the second line here, which is a competitive inhibitor, a fixed amount has been added, we reach the maximum rate of reaction bit later. We have reached the maximum level of reaction bit later. And the reason, because there is a competitive inhibitor. We said that it's not bound permanently, it comes off. Eventually, all the enzymes are, they bind to an all the active side of the enzyme, they bind to a substrate. But it takes time, because inhibitor is bound to, when it comes off, a substrate can bind to it. Eventually, all the enzymes will have a substrate fitted in, will have a rate of reaction, but it takes time. And that's why the delay is more. And we mentioned that in here, as you can see, we are increasing the substrate concentration. And as we have increased the substrate concentration, the impact is reduced. The impact is reduced, but eventually, even if you did not increase the substrate concentration, eventually you do get a maximum rate of reaction, as you should do, but a bit later, because it's not permanently bound. But the effect, the rate of reaction, as you can see here, the rate of reaction is slower compared to here. This is more steep, this is less steep. That rate of reaction can be reversed or can be reduced, meaning the impact can be reduced by adding more substrate. The more you add, the more you reduce it. Let's go into our non-competitive inhibitor. Looking at the enzyme here, we have the active site, we have another site. This is called allosteric site. This is the first time you're hearing this. So active site has nothing to do with this. So this is our inhibitor and this is our substrate. A massive contrast. The shape is just different. There's nothing similar to it. So in a non-competitive inhibitor, the inhibitor binds to an enzyme away from the active site. Keyword to mention, away from the active site in your answer. Should I make that bold? And this area is called allosteric site. So it binds here. And this allosteric site, what it does, once it's bound to it, it changes the shape of the active site. It causes the active site to change shape. So therefore, the substrate is unable to bind to the active site. It has been changed. Now this is permanent, meaning that you cannot reverse this. The substrate, the inhibitor is not competing for the active site with the substrate. That's why it's called non-competitive inhibitor. This effect cannot be reversed. This is permanent. Even if you add lots of substrate, you cannot reverse this, because in other words, you have damaged the enzymes. You have changed the structure, changed the shape of the active site, which means, in other words, you can just say it's denation. But although it's not denation, but the same concept is there, it will not be functioning at all. So we can see here, this is a green line here. This is a competitive inhibitor. We have added our competitive inhibitor, a fixed amount, okay? So let's say 50% of the enzymes were affected, which means 50% of them what are non-functioning anymore. They are non-functioning because active site has been changed. And this is why the maximum rate of reaction is less compared to the other ones, because enzymes are deficient here, you can say. Although they are there, but they are not working. 50% of them is not working, and although you are adding lots of substrate, you cannot go any further because all your enzymes are fully occupied and half of them are not even working. Okay, so thank you for joining for enzyme factors affecting enzyme. For the next, I'm gonna have one more presentation where we're gonna tackle the exam questions, trying to get you your grades, trying to see where people go wrong and how can you get the full marks and get your top grade that you deserve. Thank you for joining.